Hey, I am Dani, and today I will talk about the data center networks. I read an article that shows some way of reducing energy consumption. In this article, they use SDN-based data center and it shows some strategies and topologies. I will explain the theoretical base and some details of this article. A data center a data center is a physical or virtual facility that companies use to host applications and data. This is used to make the data and the applications safe. We need hosting somewhere, so data centers. And topology is the way of the network elements are structured. These elements could be switches and the servers. And to understand how we can organize some topology, I will show two types of topology, B-cube and fat-tree, to we compare each other. So B-cube adopts a server-centric model, enabling the use of commodity switches. And commodity switch is a standard switch with no manufacturer-specific customizations or functionality. At B-cube, each server is equipped with a small number of network interfaces, typically no more than 4, and multiple layers of switches with few ports are used to connect all servers. And the topology fat-tree is organized in a different mode, is organized in a K&R tree structure. This topology is focused on answering of the scalability network. So I want scalability large network with this topology. For these servers, will not be part of the data forwarding. How we can see in this slide in the first image. I have the servers here, and they are connecting just with the switch edge, and no other switches. The switches could connect each other, but not more than one switch with the server. And this is opposite of the B-cube, then where I can connect the server with more than one switch and switch then more than one level of switch. And this that we have in B-cube is a recursive model of topology, because I can connect it to level 0 with the server, and I will connect this server with the level 1, and if I have to level 2, so each block will make this recursivation. And the main difference between these top two topologies is that the fat-tree is speed of the links is faster than B-cube because it uses more than one type of links, while in B-cube links are the same and the energy cost of all switches are the same. And to understand what is a software-defined network, I get this image that shows how is a network traditional and the software-defined network. Software-defined network is separation of the control. The traditional control and data plane will be together. And in the software-defined network, I will separate this and create a control machine that will connect with each switch. They are programmable. This is a good difference because this will permit that we can programming by external applications, and this allows energy management. Other difference is that in software-defined networks, open interfaces between devices in control plane. And the article analysis will explain flow mapping strategies that I will explain a little more in other slide, and the influence of different overload factors and increasing energy saving in data center network. And my favorite part is that they show that have a library in Python to simulate a data center. And with this library, we can make different types of topology and simulate the energy cost of each topology. So I can compare the cost of energy of many topology in less time. And they create an algorithm that use based pin packing problem in combination with the Dijkstra algorithm. Dijkstra algorithm is a famous algorithm that will search the shortest paths, and they use theories first fit, best fit, and worst fit. The best fit will look the first path that meets with the condition necessary, so it's the first result. And the best fit will search by the best case, so the best case will be the smallest bandwidth capacity that is sufficient to meet the flow's demand. So I will consume the less capacity and I will get the same result. And the worst fit is the opposite. I will use a lot of capacity, a lot of demand, with not so many demand necessary, and I will the cost of capacity and the recurses will be large. And with these three types of strategies, I can compare and then really know if my data center will be always good or sometime it could be the worst type of data center to my objective. And I could compare this with other types of strategies to define which data center I want. And in the article, they show some energy management strategies to reduce consumption, such as on-off switches and links, whose purpose is to turn on and off data links and idle equipment. So when I don't use this, I will turn off, and I will verify this to turn off. But is algorithm, so this will happen automatically. And mapping of traffic flows so that the network's equipment that is not being used is turned off too. And the link speed adaptation can be used to reduce the speed of port based on its utilization according to the workload. And I will put in the description of this video the links to the article of this guy and the dissertation that he do. In the dissertation, you can find more details and more information about other topologies and more explanations about the experiments. Bye bye!